Alright everybody, back to our plans for world domination. As you recall, step 1 was being able to solve any triangle, whether it's acute, right, or obtuse. Along those lines, we talked about the law of sines in the last video, which has an equation representation like this. This three-part equation must be true of any triangles where we know an angle, a side, and another angle, or two angles and a non-included side. This one's always been the easiest one for me to remember. It's called the law of sines, and it has the sine of each angle in the top of each expression and the length of the opposite side in the bottom. All of these ratios will be equal to each other if we happen to know either of these circumstances. So just a quick run through. Now, knowing this information, we can certainly find the measure of angle B by the triangle sum theorem and replace that in our equations. Now it's a matter of setting up proportions and solving for the things we don't know, namely the lengths of side A and C. So we can easily solve for A here. It's just an algebraic process, cross-multiplying, then solving for A, and calculating this fraction on our calculator. And we end up with a length for side A of 14.84 units. We can do exactly the same thing for side C. So that's just a little reminder of the law of sines, part 1 here. The next thing that we need to learn is the law of cosines. If we happen to know either of these two things about a triangle, the lengths of two sides and an included angle, or the lengths of all three sides, again, we know that there is only one triangle in the entire universe that will have these measurements, and so we'd love a way to be able to figure out the rest of the measurements of the triangle because we know there's only one that exists. And the law of cosines helps us to do that. Back to our dear old friend here, triangle ABC, we can write the law of cosines in a few different ways. These equations have to be true in the case that we know SAS or SSS. The law of cosines is meant to give us the relationship between the three side lengths and one of the angle measures in triangles where we happen to know side, angle, side, or side, side, side. So in the case that we happen to know angle C, this relationship has to be true. If we know angle C, we know B, and we know A, then this long relationship between C, A, and B has to be true. And in fact, this looks a whole lot like the Pythagorean Theorem. And in fact, what we're doing is modifying the Pythagorean Theorem so that it can be true for acute and obtuse triangles as well. You'll talk a little bit more next year about why this works out the way that it does, but this year we're a little bit more concerned. But for right now, we're more concerned with just being able to do the calculations. Let's take a look at an example. So in this triangle ABC, we know A, B, and angle C. So let's fit this into the law of cosines. C squared is the thing we don't know here, because we don't happen to know the value of the measure of side C. But everything else we can fill in. And here, C is 56 degrees. Though there are a lot of things going on in this equation, it's really not that hard to figure out with the help of a calculator. So let's run over to the calculator and see what we get for C squared when we enter everything on the right-hand side. So, here we have 9 squared, so that's A squared, plus 8 squared, well that's B squared, minus 2, which is part of the equation, times 9, which is A, times 8, which is B, times the cosine of 56. And 56 is our measure of angle C. This is all we need to enter in order to find the square of side length C. So here we get 64.48. Let's round to the hundredths. Now this is the square of C, so we really need to take the square root of this in order to get our final answer. I'll make use of the answer key, which is right above the negative key at the bottom of the calculator, so we can make an accurate calculation for C itself. We end up with 8.03. And this doesn't seem like an unreasonable number. But we haven't quite solved this entire triangle yet. We still don't know the measures of A and B, and we're going to have to solve for at least one of them in order to use the triangle sum theorem to solve for the other. Lucky for us, now that we know all three sides, we can use the law of cosines again and solve for one of the angles that we don't know. Let's solve for angle A. If we want to find angle A, we're going to have to use the version of the law of cosines that contains the cosine of angle A. That's the first one here. So let's write that down and fill in what we know and solve for what we don't. So we know everything here except for the cosine of A. Let's do some algebraic manipulation here and figure out what we can put into the calculator. To get the cosine of A by itself, I'm going to do a little trick. Let's move everything in this term over to the left-hand side by adding it there. That'll make all of that positive. Then, I'll take the 7 squared on this side and move it over here by subtracting it. That'll give us a positive coefficient on the cosine of A, which will make this a little bit easier for us to solve. Now let's solve for the cosine of A by dividing by the coefficient. Again, we end up with a pretty complex expression on the right-hand side, but I don't think that it's anything too tough for our calculator to handle. So let's enter everything on the right-hand side here into the calculator and find the cosine of A. That's the value for our numerator, and that's the value for our denominator. Now we can use the arrow keys to select each of these in turn and do the division. So we end up with the cosine of A being 0.6186. Let's write that down. Now if we want to solve for A, we have to ask ourselves this question. What is the angle whose cosine is that value? Because that will give us A. Our calculator can help us out. Second cosine gives us the inverse cosine, so we ask the question, what is the angle whose cosine is? I'll select that value and put it in the argument. This tells us that the measure of angle A should be 51.78 degrees. Does this seem reasonable? Let's take a look at the diagram again. Yeah, that seems pretty reasonable to me. Now it's just a matter of solving for angle B using the triangle sum theorem. 180 minus 56 minus our 51.78 gives us 72.22 degrees. Now, only after all of this work have we actually solved this triangle. We know all three sides, we know all three angles. It actually took 2 applications of the law of cosines, but we made it through, and the calculator I think was a big help, and I think it will be a big help on all of the problems that you're going to use for this section. You don't have to worry about memorizing everything having to do with the law of sines and the law of cosines. You'll have those notes in front of you when you're taking the test. I certainly suggest when you take the test that you make a note sheet. I think it'll be really helpful with the take-home tests. So this is all the information that you're going to need to know. I'll come back in the next video and we'll run through a few examples of the law of sines and the law of cosines. Thanks so much, everybody.